Hey, this is Dr. Frank with the Church of Rational Truth. Today we're going to talk about a big paper that was published in Nature this week or last week. That was a study that was done on tissue reperfusion in pigs. It was done with a Tissue X system, basically that this company has made that reperfuses tissues after death. And we're going to talk a little bit about why that's a big deal. We've talked previously about what happens during death. Basically, that death is not some instant thing that happens all at once, that different tissues in our body kind of die at different rates. The ultimate death is usually considered brain death when we have done the damage or lack of perfusion to the brain to cause it to cease functioning, and that is generally what is considered death. This company or this group, what they've been doing is trying to do reperfusion therapy. So basically, trying to get blood or liquid tissues running through the body again to get them to be alive. This is what we do during CPR. In CPR, or when you have cardiopulmonary arrest, where basically the heart is not pumping blood anymore, you are pumping on their heart to try and move that blood around, because that's basically what's keeping us alive. Our heartbeat moves blood to our brain and our tissues. It gives them the nutrients, the oxygen that they need to continue surviving. Without those, they die. So usually when our heart stops or we're not breathing, we don't have oxygen, that is what causes us to die. So if you can fix that, you can keep things alive. Generally, what we have done before is when you have collapse of the circulatory system and it is not able to oxygenate itself well, so like if someone has lung failure where they have end-stage COPD, lung cancer, other damage to the lungs where they can't perfuse their body well, they can't get new oxygen into their blood. One thing doctors can do, this is all done like when people have a heart attack, brain death, and you get circulation back, or basically you want to help aid them in getting better perfusion in terms of the oxygenation in their blood. There's a thing called ECMO, which is extracorporeal membrane oxygenation. This was used a lot of times to help get oxygen into blood outside of the normal circulatory system. What the lungs do naturally in the body is they are a big area that has a lot of surface area, and that surface area is exposed greatly to the atmosphere. What that does is that allows oxygen, with a little bit of help from surfactants, to exchange in and out of the bloodstream. So oxygen can move in, carbon dioxide can move out, and those gases can be exchanged, and they need a big surface area to do that. The more surface area, the more efficient that is. If you have a really small surface area, you can't move a lot of gases back and forth, but if you have a huge surface area, you can do that a lot more efficiently, and that's kind of how the lungs function. If you've ever seen lungs, they're just a whole bunch of little sacs, which basically just increases the surface area a huge amount to make it easy to exchange gases into and out of blood. What ECMO does is it tries to do that outside of the body. It basically pumps the blood through membranes that are oxygenated, and those membranes help increase the surface area to allow that oxygen to transfer in, carbon dioxide to transfer out, and then use that to help perfuse the system. If you're not getting enough oxygen on your own with your lungs, we need another way of getting it out, and that's kind of been the new standard, and you see that happen a lot of times when patients are close to respiratory failure or basically in respiratory failure, and it's very much a last-ditch effort. You don't see it a lot very commonly. I've actually never seen it in my practice when I used to do inpatient medicine, but it is something where you'll see it. I know patients in Charleston have gotten it, patients who have drowned for a long period where they're trying to resuscitate them and they might not be breathing on their own. There's a lot of examples of when it can be used, but it's very much still an extreme practice. It's not done very much, and I think if you talk to someone who is an intensive care doctor or an intensivist, they'd be a much better person to talk to about when and if this is done. Now, this is different than ECMO in that it is not just perfusing the patient or the animal's own blood. This is a good transition point. Let's talk about the actual study or what they did. They took pigs that have been euthanized and they've been clinically dead for approximately 1 hour, and they hooked them up to this system called it's Tissue X, OrganEx, I think it is. Let me double check. OrganEx, OrganEx. Basically, what that system would do is it would perfuse the tissues in the body. It would basically just circulate fluid throughout the body to get perfusion back to the tissues, but instead of just using regular blood like you'd use with a ECMO, they would use the combination of regular blood and this perfusate, which is basically a fluid full of different nutrients that they have made to make that work better. And the reason they did that is because if you tried doing this on someone who is dead with regular blood, it doesn't work. Otherwise we'd be doing it already. Basically, tissues are alive, blood counts as a tissue even though it's a liquid tissue, and as soon as someone is brain dead or not circulating and not perfusing even their own blood, it starts to die just like everything else, and it dies at different rates, and it causes different electrolyte abnormalities. Things start clotting because blood that is not moving will clot on its own, so if it just stays stagnant, it'll start clotting within the blood vessels. So they use this perfusate in addition to the circulation system to help reperfuse tissues. And they found that 1 hour after the animals were clinically dead, they were able to reperfuse the tissues. The tissues were able to get the nutrients and the oxygen that they needed to continually live past death. Now, this didn't fix brain death. These animals were still brain dead, and they didn't get new brain activity, so they're not alive, or at least not what we would consider alive clinically, but their tissues are alive. Sorry about that. Someone's calling in the middle of lecture. So their tissues are still technically living, and this goes back to our old talk about when you die, your tissues don't all die at the same time. Even though you are brain dead, you have tissues like your organs, your liver, possibly your heart. They still might be alive because they don't all die exactly at the same rate. They can live with less oxygen, they can live with less perfusion than the brain can, and so it all doesn't quite happen at once, and even though you are brain dead or dead clinically, your other tissues might not exactly be dead as well. They kind of might live on for a little bit longer because death is a process. It's not all instantaneous in most cases. So this was able to allow those tissues to stay alive despite having complete brain death or actually being dead for an entire hour. They could then bring those tissues or allow those tissues to continue to survive without dying. You might think, well, how does that help us? If I'm brain dead, I don't care if the rest of my tissues are alive. I'm my brain. We are a brain in a body, and if my brain's not alive, I don't really care about the rest of the tissues. But what is important about this is it is groundbreaking for transplant medicine. So when someone dies and is an organ donor, you have to have a team ready immediately when they die to be able to harvest those organs or to keep them as alive as possible so that they can actually get those organs, because if they're not being perfused, the organs start getting damaged, they start dying. So a lot of times you have to have the organ transplant team basically on call or ready for someone who is an organ donor to be able to donate after they've died. That might not be a problem anymore. This might be able to allow us to have someone be declared brain dead, but we might be able to keep the rest of their tissues alive to be able to then, I hate saying harvest, it sounds very inhumane, but be able to then get their tissues and not have this mad rush where, oh gosh, this person was dead for an hour before we actually got the transplant team on, we just lost all their tissues. Now this gives you a whole lot of time, and if you could keep them alive perpetually, or even for hours, days, months, I don't know about months, but the longer you can keep them alive, the much easier it's going to be to get a higher quality transplants, and this is going to save lives. It doesn't fix the mortality issue, which is one thing that we do really care about in this church, is trying to get closer and closer to immortality, or at least fighting mortality as much as we can, because it doesn't fix the brain death issue. And the same group has been working on a OrganEx perfusion system. It works somewhat differently. I'm not too sure of the specifics of it, but if we are able to fix both of those sides, or if we're able to later figure out how to fix the brain issue, this is a huge step in the right direction. This means we could possibly stave off death longer, but this doesn't solve the problem yet. It is a big step, but at least it fixes a lot of the problems with tissues and organ transplants. So fingers crossed, hopefully this is reproducible. Fingers crossed, hopefully this also works in humans. If it works in a pig model, hopefully it works in a human model, but I'm sure we'll probably be seeing more and more from this as it comes out. Let's just keep our fingers crossed that it still works. That's it for this lecture. If you want to see more lectures that are similar to this in terms of tissue reperfusion, life after death, what happens when you die, avoiding death, immortality, anything that you think is interesting, please let us know. We'll maybe use it as a topic for a future lecture. Thank you so much for watching. This is again Dr. Frank with the Church of Rational Truth, signing off, and I will see you all next week with the next lecture.